So yesterday in class, and then we just saw the brain pop video about ocean currents. Show me fingers. How many ocean current types are there?
2. Wait.
Okay, good. There are 2. We're going to talk about the surface currents, and then we're going to talk about the deep currents. So let's we're just going to recap what we talked about yesterday and today by jotting it down in your journal. You'll have something to refer back to. The surface currents are like what it sounds like. They're at the surface, but they're quite deep as well. These are going to be caused by winds and global weather patterns. Can you guys see this?
Yes.
So those surface currents are going to be caused by winds and global weather patterns. They are not caused by convection currents. Now, I'm going to try to just do a kind of a crude map of our globe. That ain't too shabby. Okay. How many poles? Show fingers. Okay, how many equators? Nice. Equator. Where is it? Okay, good. What do we know about the equator? It's hot. It's the hottest part. And we're going to talk about that later when we talk about direct and indirect sunlight. Do y'all know that the Earth is actually tilted?
Yeah.
And at a, okay, 27.5 if I remember right. 23.5 or 23.5. All right, my diagram is wrong because I did not tilt the Earth. I could do that, but anyway, we've got the equator, we've got the 2 poles. We know that it's hottest here. There are things called gyres. We didn't mention those yesterday, and we're not going to be particular about the numbers. All right, I just want you to get the idea that gyres are surface currents, and in the northern hemisphere, so this is north, right? How are they spinning?
In a circle.
Okay, they're spinning in a circle, clockwise or counterclockwise. Okay, these are spinning, and that word gyre is G-Y-R-E. So in this picture, how many gyres are there?
2.
Okay, good. There are 2. So in the northern hemisphere, these gyres spin clockwise. Whatever's going on in the northern hemisphere, the opposite happens in the southern. So they will too have gyres, but we're going to draw them go in the other direction, which is counterclockwise. So this is a gyre. I'll draw one more. Is this accurate?
Yes.
Is this an accurate representation?
No.
No. We just wanted us to have the idea that northern gyres go clockwise, southern gyres go counter. Now, the reading, hang on, counterclockwise. The reading that you guys did yesterday just suggested real shortly that animals depend on these currents, and you learned one really young when you watched the movie Nemo. Do you remember the turtle helps Nemo and... Yes. Okay, so remember, here's an example. Okay, the East, some of y'all remember the name. The East Australian, Australian. If I misspelled that, I'm sorry, Australia. So there is a current called the East Australian Current, and that was just one example. But it's nature's underground subways. So what would benefit an animal to take one of these currents?
They can go faster.
They can travel faster, and what do they not have to do?
Swim.
They do not have to use their energy to swim. So now the turtle doesn't talk and say, hey, come on, fishies, but these animals instinctively know that they've got their own subway system. So we'll just put the Australian currents in Finding Nemo. Do you guys know what to do with movie titles if you're handwriting? Capitalize number 1, and then we're gonna underline movie titles. Okay, that is, nod your head if you got that. Okay, what's the other type of current? Awesome. Okay, the other type of current, so I'm just going to divide the paper. So we know we've got surface currents here, and this half we're going to put deep ocean currents. Do we have to write the word ocean?
No.
I don't think so. So we're going to talk about deep currents. Now these currents are driven by convection. These are caused by differences. So the deep currents are caused by differences in two things. If it's involving convection, what's one of the key things of convection? Temperature. Good. Okay, so caused by differences in temperature and density. Am I still on the screen?
Yes.
Okay, deep currents are caused by differences in temperature and density. All right, we're going to use the example of the global convection current. Excuse me, it's the global conveyor belt. Global conveyor belt. Okay, and we're going to do a real crude sketch of it just so you get the idea. We're going to not use colors. We'll just make our key. Let's use solid lines or warm. And dotted lines will be what?
Cold.
Yes. Okay. So, remember Newton's first law? First law, it's one word. Inertia, yes. Objects in motion or objects at rest are going to keep doing that until what happens? Till some other force acts on it. So let's look at, we're going to start here. And y'all, if yours doesn't look just like mine, it's no big deal. You just want to get the idea, okay? All right, so this current, this warm current is moving. And what is it? Why did it change directions? It's supposed to keep going like it did. It's going to change directions. What do you think it hit? Yeah, what force do you think acted on it? Let's see. See if you can get it. We're going to come over here. Oh my goodness, it's got to turn directions. What did it hit? Land. Yes, so every time this conveyor belt changes directions, it's because it has hit a force, so it's had to change its velocity. So I am so bad at drawing arrows. So this is moving this way, I hope. All right, and then we're going to change. These waters are going to be cooler. We're just getting the idea of what's going on here. Did y'all kind of get the idea of that? If you liked this video, please like and subscribe.